Hi, hello, it's my variac and I'm going to show you how I took the variac from a more shabby state into this condition, which is pretty usable.
First thing I needed to take care of was the imbalance in the arm with the graphite rollers. The graphite rollers being the heavier part, and it would just slowly creep to one side until it was in the lowest position possible. And if you gave it a little nudge in any of the directions, it would either ramp down to 0 power or ramp up to full power on its own just because of gravity. So I decided to use the arm on the other side of the pivot to attach some weights to it to have it balanced. Here's a little demo of how I tested if it was stable. It's very far from perfect, but well, it does the job. Oh, and by the way, the graphite rollers I showed you just a second ago is actually how they looked after me giving them a little attention. Before that, they looked like this. The wiring in this variac was done with this old wire with cloth insulation and some rubber insulation underneath that cloth, which has long deteriorated and become crusty and all started slowly turning to dust. Next, I added all these plugs and banana connectors with the intention of wiring them in parallel and them being the output. Now it was time to add an ammeter and to also wire this thing up. The ammeter had to be placed a little awkwardly in the back because otherwise it would hit the whole roller assembly, and I had to cut out a little holder for it, which I did like this. Then I did the wiring. I didn't really pay much attention to making it beautiful. Here you can also see the soft start switch. This is a manual 3-position switch, which either is off, then it switches the variac through a resistor, and then switches the variac directly. I tried wiring it with some pretty thick wires, but it's nothing too much, the wire that's used for the actual transformer. Here I used some copper jumpers across the banana plugs just to make my job a little easier. It's extremely overkill, but it looks nice. Now, just for a small exercise for the whole system, I decided to power a mod with it and draw some small arcs. It's more as a test of if the wiring is even correct than anything else. By the way, I really didn't have to use gloves to do the variacing here. The whole structure, the metal structure, is grounded. The arm and the support structure, it's all on ground. Then I decided to slap 2 mods together for some more power and give it a try as well.
That's nuts. They're pulling 8 amps at idle. We back off a little, now they're pulling just 5. The arcs are still pretty sizable. I think they don't like the voltage. It's too much, the cord don't like it. Saturation, you know. Now let's take a quick look at the current draw. Yeah. They be humming. The ammeter doesn't like it. Yeah, they begin pulling way too much current, like in short circuit mode. It's early. Okay, now. Yeah, now. So this is it's pretty good arcing already. I mean, you know, about what you'd expect from a single mod.
This whole time I was thinking, how am I gonna add a knob to this variac? It didn't seem fitting to just use a regular knob. And then I saw this contraption made by Trent, who 3D printed this steering wheel like big knob for his variac stack, and I thought I had to have that. So I looked a little online and I found a cheap tractor steering wheel, I ordered it and it turned out to be perfect in size. It just one issue, it had this metal piece inside, which I had to somehow remove. After some thinking, I figured that, well, perhaps induction heating is the best choice here. I thought heating the metal outside from the outside would make the plastic soften, and at that point I could just pull it out. Leaving the metal in was not an option because it would collide with the shaft of the autotransformer frame. So I called up a friend of mine who has a setup capable of induction heating. He originally built it as a high voltage power supply, which was supposed to work with this big ferrite transformer, high voltage transformer. Here you can see some arcs that were pulled from that transformer. It's now just sitting around, sort of doing nothing, and we were able to quickly throw together a simple induction heating setup, which worked well enough to get their job done. After that, I went with it to a quick trip to the mill to flatten out the bottom of the steering wheel, and then I had to shrink this washer that was on the shaft around which the whole assembly was rotating around the transformer. The washer previously was way too big, but well, I managed to find these two beautiful copper washers which fit wonderfully, and look at this. One of them, it's just so good. And here's how I terminated this. My point was to shrink the outer diameter of these washers, and so the steering wheel goes on like this, and it shall be mounted very soon. I've began measuring these, and it turns out there's a different spacing between each one of them, so they don't form a triangle. Well, they do, but it's not a triangle with a equivalent length arms, so it's 2.7, 2.8, and 2.9. So I simply put a piece of paper, scribbled it, stuck it on here, and used a punch to punch them in. About the dodgiest setup ever. No clamping first on this because, well, you hardly can clamp something with such a surface. I didn't really want to figure out a better setup, but I got through it. This is a pretty easy material to work with. As you can see, well, it didn't go perfectly. That's because the triangle is not a fucking triangle, the setup of the holes. But well, you know, we'll see. I sincerely hope that this works out, because I have strong doubts looking at the layout of these holes, but these ones look fine. Well, okay, so I ended up opening these holes up to 3.3, and as you can see, the thing now works beautifully. And seal it off. Okay, now that's it. That's the variac. As you can see, works very well. Allows for pretty easy control. I like it. I must admit, it's probably one of the most fun things I've done in a long time. This has been inspired by Trent. So I bought the steering wheel from an actual tractor unit, a smaller one. It's entirely made out of plastic of some sort. And so that means isolation. This is on ground, of course. This is on ground, this is on ground. It's only these that are right, but these are isolated. This is beautiful. I don't even have to touch the ground. It's isolated. As you can tell, a little bit of time passed, and it's gotten colder, and I've gotten sick. But this cable, this rubber cable that I bought for this variac, and this beautiful plug, but the focus is the cable. This cable stunk, okay, with rubber, so bad that I couldn't stand it. Okay, I left it in my room for one day, and I didn't expect the consequences, which were that my whole room stunk with the cable, the rubber cable, that emitted the stench of rubber. So I decided to connect the plug, finish the connections on there. I mean, prepare them for connection to this. Anyway, 3 times 2.5 millimeters square copper, and a beefy ass plug, looking pretty good.
all tightened very well, and it's IP54 rated. this is, I believe this to be watertight, this seal, but the rest not, and this certainly not. Anyway, with this beautiful cable, this variac is now far more usable. I also bought this while I was at it. It's extension cord with these dudes, and has this whole thingamabob, so you can sort of do your thing. Oh yeah, okay, that sits in there pretty well. It's got the same plug. They are sisters, and you can use the infinite electricity glitch, okay, to power anything. And the current that's gonna flow is the rating on the wire. That's the rating. That's what it's there for. Anyway, nice extension cord. Pretty cheap as well. About 20 bucks. No, less. Like 15 bucks. Not bad. Not rubber, PVC isolation. It's 3 times 2.5. So same as this, just not rubber. Fine, I guess. Yeah, so that's that. The variac can now be used. It's finished, I think.